everybody, it's Luke back here again with another episode of Sandwiches and Math. Today we're going to be talking about integrals, derivatives, and limits. And our sandwich, well, I don't know what our sandwich is today, folks, but let's find out. Compliments to the chef, Bonnie Barrett, shipped it up fat with another, it's probably really fat Sammy. Let's get in on here, zoom in. Ciabatta bread, you already know, some rosemary, if you zoom in right about there, some rosemary flakes, you already know, cooked right in. Oh, turkey, garlic aioli, some cheddar, and some lettuce. You know, I gotta say, oh, mustard too, wow. You know, I gotta say props to Bonnie Barrett. She's really just on her game right now with the whole Sammys, but we're gonna get into some math, folks, so let's go. Okay, guys, so we're gonna dive right in with integrals, and just to preface the three things I'm going to be explaining to you guys, I'm not going to be teaching them to you on a very conceptual level. They're just going to be really tricks to help you understand really basic calculus problems and concepts that you're going to find in your AB or BC class. So here we go. Here's our first example of an integral problem, and it's the integral of 6x squared minus 4x plus 3 dx. We're gonna take a quick sandwich break. I gotta say, this sandwich is pretty good. I'm 2 bites in and I'm really loving it. Here we go. Really good. Not gonna lie. Pretty great, really balanced, you know? Yeah. So, when you see this problem, you have to notice that there isn't anything here or here on the integral. And what that means is, regardless of whatever we do between here and here, we're always going to add a constant at the end, plus c. Constant represents c. And so, the way you do an integral, a basic trick, is you just take the exponent, you add 1 to it, and then you divide what your new exponent is. So, in this case, it would be 6x to the third power now, over that new number, 3, and we can do that again here, minus 4x squared, because this is to the 1 power. We'll put it over 2, and then similarly here, because there's no x, we're going to actually just add an x, and it's going to be plus 3x, and it'd be to the 1 now, and it'd be over 1. And we can reduce this, and it'd be 2x cubed minus 2x squared plus 3x plus c. So that's how to do a basic integral problem. More sandwiches time. So getting back to the sandwich, as you can see, there's actually some ham right here. You know, I thought it was just turkey, and my mom was like, boop, not just turkey, also ham. I was like, damn. It's so good. All right, let's do some more math, yeah? Okay. All right, guys, so now we're going to start doing another basic derivative problem. And like I said before, you know, I'm not really going to teach you anything conceptually, you know, just going to tell you how to really finesse. Miss Denny said it herself verbatim, you know, maybe you'll understand stuff conceptually around year 2 of calculus, because to expect yourself to actually understand anything really at an in-depth level right at face value is pretty challenging, and, you know, you got to be pretty smart. But, you know, I'm really more focused on my sandwich eating career at this juncture in time, so, you know. All right, we're going to do the problem f of x equals negative x squared plus 3x minus 5. So when someone says to take the derivative of something, and honestly, I don't even know if that's spelled right, but, you know, we're doing math, not English, so who really cares? But, you know, this is supposed to say derivative if it actually doesn't. So when you're doing the derivative, you're going from f of x to f prime of x, because this is the derivative of that. So let's just do that real quick, yeah? So with a derivative, instead of adding, you're going to take that exponent and move it in front of the variable. So now it would be negative 2x, and you would add just a 3. So instead of taking this 1 and well, what we actually do is we take this one and we move it in front, and then we we cancel this x out. So now we just have 3. And similarly with this 5, if there's not a variable attached to a number, then all you got to do is just cross that little guy out. So there's no 5. And this is our answer. So the derivative of f of x is equal to negative 2x plus 3. And that can be expressed through f of x. All right, guys, checking back in with the sandwich. I'm about halfway down, and we're about 2/3 the way done with my my little presentation about calculus. And, you know, I just got to say that sandwiches are just really good, you know? Like, you can kind of put anything on them, and they're just going to taste great, like, damn near regardless. And it's the same thing with calculus, you know? You can do whatever the hell you want, and either way, you're going to get some type of answer. It might not be right, but, you know, you did your best, so that's all that you can really ask for. Hopefully you get it right, just like a sandwich. Hopefully, you know, you make a good one. But either way, you learn from it, and, you know, you just keep chugging. Keep eating your sandwich. Keep doing your calculus, you know what I'm saying? All right, let's do limits. All right, so here's our example problem. It's going to be the limit. So x is approaching 3. And the equation is 2x plus 5. So with a limit problem, what you have to remember is that before really doing anything, you can always plug in your x value into your equation and see what the result is. So we know that the two numbers that we have to use are approaching the number 3 from the right and from the left. And so the two numbers we're going to plug into the same equation is going to be 2 times 2.9999, because that is coming from the left, going to the right, and it's going to be as close as you can get to 3 without actually touching 3. And like I said, that'll be explained later in more of your calculus stuff, but just understand that you have to input a number that is really, really close to 3, but not actually 3 on both sides. So our other number that we're going to do, plus 5, and our other number that we're going to do is 2 times 3.0001. So it never actually touches 3, but it's really, really close to 3. We're going to do plus 5. And so this equation that I created is very much solvable, and you'll see that in a second. But you have to realize that limit problems become far more complicated, where there's holes and steps and indeterminate functions and a 0 over a 0, and you have to use a bunch of different rules. But understand that this is the most basic function, and you can always do this for every limit problem. You can always plug in your number x into your equation and see what you get. And we're going to get real numbers, and we're going to get a cool answer. It's going to be 11. And yeah, so for this function, my answer would be, if I were to plug it into a calculator, would be 10.9998. And with this equation, if I were to plug this in, it would be something along the lines of 11.0002. So, if you look at this number, and you look at this number, you're like, those are kind of close. I'm thinking those might have something in common with one another. Well, boom, they're actually really, really close to both the number 11. So if you were to plug in a really, really small number that is close to 2.999999 and 3.000001, they're not actually the number 3, but they're really close to the number 3. If you were to plug that into this function, you would get a number really, really close to 11 for both things. So we now know that as the limit as x approaches 3 for the function 2x plus 5, we know that our answer is 11. And that is a whole lot of gang things. All right, guys, I'm just finishing up my sandwich. Pretty satisfied with today's work. You know, you just got to stop and think, like, man, sandwiches are good. Calculus is enjoyable. You know, the good things in life. All right, everybody. Wow, I have a unibrow. Damn. All right. Peace.